This is Ms. Humbert here, and welcome to Unit 1, Notes 2. So in Unit 1, Notes 2, we are going to be talking about solving inequalities. We're going to use a lot of the same steps we learned on Notes 1, except now we're going to be applying them to inequalities. So let's go ahead and take a look at what that's going to look like for us. So it's very important to remember those 4 steps we talked about yesterday. The first one being to simplify the equal sign by distributing and combining like terms. The second one, gather variables to one side of the equal sign. So that's adding or subtracting those terms so that they're on the same side. The third one, use addition or subtraction to cancel the constant. And the last one is multiplication or division to cancel out that coefficient. Okay, so we really are just working to get that letter completely by itself. So let's go ahead and let's just do a brief review of those solving equation problems. So we're going to take this 2 and we're going to distribute it in. So negative 2 times 3 is going to give us a negative 6x. Negative 2 times 5 is a negative 10, and that's equal to 4x plus 20. So now what I need to do is I need to get my x's to the same side. So I'm going to go ahead and subtract 4x from both sides. Now this can really confuse students. Negative 6x minus 4x is not negative 2, okay? When you're adding two negative numbers, it's actually going to get more negative. So you end up with negative 10x. And then minus 10 is equal to 20. So now I need to get that minus 10 over to the other side. So I do that by doing the opposite. So I'm going to go ahead and add 10 to both sides. And then I get negative 10x is equal to 20 plus 10, which is 30. So then I'm going to go ahead and divide both sides by a negative 10. And when I do that, I get 30 divided by a negative 10, which is negative 3. Okay, so that's your final answer for number 1. Let's take a look at number 2. So we're going to distribute in to each of those parentheses. So it's important that we make sure we do it to each one separately. You only distribute to what's in the parenthesis that follows. So negative 7 times p is negative 7p. Negative 7 times 7 is a negative 49. Okay, 3 plus p is 3p. 3 times negative 4 is negative 12. Now all of that's going to be equal to negative 17. So step number 1 is still happening here. We need to combine our like terms. Well, anything with a p is going to be a like term. So negative 7p plus 3p is going to be negative 4p minus 49 minus 12. Well, let's just do that in one step. So then I'm going to have minus 49 minus 12. Again, when you add two negative numbers, it's going to get more negative. So that's going to end up being minus 61, and that's equal to a negative 17. So now I need to get that minus 61 over to the other side. So I'm going to go ahead and add 61 to both sides. So then I get negative 4p is equal to 44. So that negative 4 is being multiplied by the p, so I'm going to go ahead and divide both sides by 4. And then 44 divided by negative 4 is going to be negative 11. So that's our final answer for number 2. If you're still struggling with solving equations, please make sure you come and let me know. I think that'll really help you out. So let's go ahead and let's take a look at number 3. So we're going to distribute in the parentheses. So I have 8a here, negative 4 times negative 5. When you multiply a negative times a negative, you're going to get a positive. So that's going to be 20a. Negative 4 times negative 2, again, is going to be positive, and you're going to get 8, and that's equal to 12a. So then I have 8a plus 20a. That's going to give me 28a. Plus 8 is equal to 12a. So now I want to get my a's on their own side. I see that there's nothing being added to that 12a. So I'm actually going to bring that 28a over to the other side. If you did it the other way, it will still work. So then I get 8 is equal to negative 28a plus 12a, which is going to give me a negative 16a. So now I need to divide both sides by a negative 16. So what I end up getting is that a is equal to 8 over negative 16. Well, I'm okay with you writing things in fractions, but you do need to reduce them. So both of these numbers are divisible by 8, so I'm going to go ahead and do that. So it actually reduces to be that a is equal to a negative 1/2. Okay? So let's go ahead and let's take a look at number 4. So for number 4, what you're going to do is you're going to distribute in here, and you also need to distribute in here. You need to do that with all of your parentheses. So 9 times b is 9b. 9 times negative 4 is negative 36. And then we have minus 7b, and then we're going to distribute on the other side. So 3 times 5 is 15b. 5 times negative 2 is a negative 10. So let's combine these two b's. So we have 9b minus 7b. That's going to give me 2b, or not to be, just kidding. Then minus 36 is equal to 15b minus 10. So what I'm going to do is I'm going to subtract this 2b to be on the same side as the 15b, because I don't know about you, but I like positive numbers. So then I get 13b minus 10. So now I'm going to go ahead and add that 10 over to the other side. So I get negative 26 is equal to 13b. Then I'm going to divide both sides by 13. And when I do that, I get b is equal to a negative 2. So that's my final answer for number 4. Now let's dive into some of that inequality stuff that we've been talking about, okay, or that we're going to talk about. So what we want to do is just create a chart to kind of help us go through the different parts of inequalities. So first thing I want to talk about is less than. So less than is when you have something that's smaller than. So these words right here, the not as much as, fewer than, this stuff right here, that really helps you to know what you need to look for when you're doing word problems. So it's really important that you write those down. Then when we're talking about strictly greater than, in a word problem you would look for the phrase more than or, greater than. Okay, when you see less than or equal to, you know it's the equal to because you can see that line underneath the inequality. So when you see that line, you know that it's a or equal to. So these words right here will tell you when you're going to need that extra little line underneath. And last but not least, we're going to talk about greater than or equal to. And here are the words that will tell you that you need that amount. And we're going to do some practice with that once we get used to solving equations with inequalities. Okay? So let's go ahead and let's take a look at that. Here's something that's really, really important for you once we start solving these equations. When you are solving inequalities, you need to reverse the inequality symbol. Okay, you need to reverse the inequality symbol when you are multiplying or dividing by a negative number. When at any point in the problem, if you multiply or divide by a negative number, you need to remember to flip that symbol. So let's go ahead and let's take a look at number 5. So for number 5, we need to start by distributing. So it's the same step. So I'm going to multiply in the negative 4. So I have negative 4 times 5 is negative 20. And then negative 4 times negative 8 is I forgot the W, is a positive 32, and that's going to be greater than 52. Forgot my negative sign too. Wow. Struggle. Okay, so now we're going to bring that 32 over to the other side. So I have negative 20W is greater than, and then 52 minus 32 is going to give me 20. So now I'm going to divide both sides by negative 20. Now when I say that, I immediately have these little alarm bells going off saying, hey, watch out there, lady, you're dividing by a negative. Okay, so when I divide by a negative, I need to take where that's located and flip it the other direction. So I have W is less than negative 1. So here's what we're going to do for the number line. We're going to open this up, this circle, and we're going to call this negative 1. Now, it's open because there's no line underneath there. When there's a line underneath there, we're going to use a solid dot. But because there's no line underneath, we're going to use an open dot. And we want W to be less than negative 1 or smaller. Anything smaller goes to the left. So if it's less than, you're going to go on this side. And then over here, it's going to be more than. So if we want something greater, we're going to send that over to the right side. Okay, now let's go ahead and take a look at number 6. So the first thing I want to do is get that 13 over to the other side. So I'm going to go ahead and subtract 13 from both sides, if it'll let me. Then I have negative 4k is less than or equal to 14. So then I'm going to divide both sides by negative 4. I don't know if you guys have alarm bells, but I sure do. Okay, I divided by a negative. I need to flip my sign. So then I have negative 14 over 4. Now that fraction can be reduced because 14 and 4 can both be divided by 2. So that's going to give us a negative 7 halves. So now I notice that there is an or equal to sign on the bottom. So I'm going to go ahead and shade that in darker. So I'm going to call this negative 7 halves. Okay, so then it's greater than, and remember that greater than means I need to go to the right. So I'm going to go ahead and shade that arrow in to the right to imply that anything from negative 7 halves on up is greater than. Let's go ahead and let's take a look at number 7. So what we need to do for number 7 is we need to start by getting our like terms on one side. So I'm going to start by subtracting 4x from both sides. 9x minus 4x is going to give me 5x. You could have gone the other way. It'll still work out the same, but you'd have to pay attention to dividing your negatives. And let's be honest, I'm too lazy when I don't have to do that. So then I want to get that 5 over to the other side. So I'm going to subtract 5 from both sides. And then I get 5x is greater than 15. So I'm going to go ahead and divide both sides by 5. And I get that x is greater than 3. So x is strictly greater than. So I'm going to do an open circle because there's no line underneath. And since it's greater than, I forgot to subtract the 5. Whoops, that'll be a 10 and this will be a 2. Congrats, Miss Humbert, you can do math. So then you're going to go ahead and shade that to the right. And I'm going to label this point 2 because x is greater than or equal to 2. Let's go ahead and let's take a look at number 8. So on number 8, what we're going to do is we're going to try and get that b by itself, just like always. So I'm going to start by subtracting 5 from both sides. Maybe I'm going to try real hard. Doesn't like that 5 there. Hello, 5. Hello. Are you there? Okay, there we go. So then I get b divided by negative 3 is less than 10. So b is being divided by negative 3. So in order to get it over to the other side, I need to multiply by negative 3. Again, what am I doing? Well, gosh golly, I'm multiplying by a negative number. Better flip that symbol. So now I have that b is strictly greater than, oh my gosh, I did it again. This should be 5. I should not be copying from up above, huh? I guess math is too hard at the beginning of the year. So it should be strictly greater than negative 15. So when I get negative 15, I need it greater than, so it's going to go to the right. Now, let's go ahead and let's take a look at number 9. So it says an amusement park charges $15 for admission and $2.50 for each ride. You go to the park with $60, write and solve an inequality that represents the possible number of rides you can go on. Well, if you're going to an amusement park and you have $60 in your pocket, can you spend more than $60? No, that's what's in your pocket. So whatever you spend has to be less than, or it could be equal to. You could spend exactly $60. So when I go there, I got to shell out $15. That's just to get my little booty through the door. Okay? Then once I get in, it's like, then I have to pay the $2.50 per ride. It's kind of like the state fair. You pay to go in, then you just pay more money to eat food. So for every X ride I go on, it's going to cost me $250. So X is going to represent the number of rides that I can go on. So I need to solve this to figure out if I can even go on a ride. So I'm going to go ahead and subtract 15 from each side. And then I get 2.5x is less than or equal to 60 minus 15, which is 45. Then divide both sides by 2.5. And then when I do that, I end up getting x is less than or equal to 45 divided by 2.5, which is 18 rides. If any of you have ever watched Channel 45, good for you. Okay, so that's how many rides. I could go on 18 rides, or I could go on less than 18 rides. Could I go on 19? No, because it has to be less than or equal to 18 rides. Let's go ahead and let's take a look at number 10. You have $18.50 to spend on a pizza. It costs $14 plus 75 cents for each topping, tax included. Right, and solve an inequality for how many the maximum number of toppings you can have. So I have $18.50. If that is all I have to spend without tapping into my dad's pocket, that's all I have. It has to be equal to that, or it has to be less than that. So starting out, I have to pay $14. That's just to get me the bread, the sauce, and the cheese, right? But I want more than that. I want flavor. I want pepperoni. I want anchovies. Just kidding. I don't think anybody wants anchovies. So I'm going to let X represent the number of toppings. So for every X topping I buy, it's going to be 75, if it has a thing with 75 cents. So now I need to solve this for X. So I'm going to start by subtracting both sides by 14. So I get 0.75. X is less than or equal to 18.5 divided by, 18.5 minus 14, which is going to give me 4.5. So now I need to take that and divide it by 0.75. And notice it's dividing it by 0.75. It's not dividing it by 75. Then you really have no toppings. So then 450 divided by 0.75 is going to give me 6 toppings. So I could have up to 6 toppings on my pizza. I can't have 7 though. If I have 7, I'm over that 1850. If I have 6 exactly, I'm going to hit that 1850 exactly. So this will help you budget out your Friday nights, okay? You're welcome. So let's take a look at number 11. For Park College's basketball games, it costs $15 to attend. The season pass costs $170. At most, how many games could you attend at the $15 price before spending more than the cost of the seasonal pass? So if I flip my page over, whenever I see more than, that chart tells me that it means greater than. So I don't want to spend more than that cost of a season pass, which is $170. And I'm going to let X represent the number of games I went to at the cost of $15. So I just need to solve this for X. So I'm going to divide both sides by 15. X is less than 170 divided by 15 is 11.33. Now think about this logically. Can I go up to the ticket booth and I can say, yes, I'd like to pay for 0.33 of a game. I promise I'll leave partway through the second quarter. Is that going to work? No. If you pay to go to the game, you're going to pay to go to the whole game. So the point is that you cannot go to 12 games. Because if you go to the 12th, you're going to be past that 170 because you can't pay for 0.33 of a game. So that means that we have to go to less than 11 games. So the maximum amount of games we can go to is 11. We can't go more than that, okay? So that concludes your note video for today. Again, please let me know if you have any questions. Thank you for listening.